Okay, we got a kicker punting a ball from the height of 2.5 feet. The initial vertical velocity is 45 feet per second. And when does the ball reach 5.5 feet? So you do have to know, before you kind of jump into this, the general form for this type of problem. It's the equation that we use when our units are feet and seconds, and we're looking at a projectile, something to being hit in the air, a football or a soccer ball being punted, right? Would make a projectile, right? It's going to go up and it's going to come back down. It's going to make a parabola. We know we're going to have an x squared kind of equation. So this is the general form. H or h of t, right, is equal to negative 16t squared. So the coefficient on the t squared is always negative 16. It's a constant due to gravity. And then on our t term, right, because our quadratic is, normally we look at it like this. Here, I'll write it up here at the top in another color. Y equals ax squared plus bx plus c. Normally it looks like that. I changed my variables. Instead of y, I did h of t. It's the height in terms of time. And my x is my time because I'm tracking time, right, per second. And I'm tracking distance. Okay, so then we have a coefficient in front of t, right, because we would normally have an x term. We're going to have a t term. And it's typically written like this, v sub 0. It's the initial vertical velocity. It is the very fancy term for basically speed when it's first kicked, right? It's your speed. And then your last thing is your constant, right? What we call our c. But we're not going to write it as c in this context because it gets its own fancy notation. It is s sub 0, and it is the initial height, right? It is the initial height. So we're actually given all this stuff in the problem. The kicker punts a ball from a height of 2.5 feet. So that is going to be your s sub 0. That is that number right here. It's punted from 2.5 feet in the air. Then they also tell you it is going at 45 feet per second. That is going to be this guy. So here, our s sub 0 is going to be that 2.5. And our v sub 0, our initial vertical velocity, is going to be 45. So now that we know that information, we can write the equation. H of t equals negative 16t squared plus 45t plus 2.5. Then they want to know, when does the ball reach 5.5 feet? So we want to know, when is the height 5.5 feet? Well, that is this. Basically going in here, we want to know when that happens. So we're going to replace the h of t with 5.5. So now the equation is going to look like this. Oops, move it up just a little bit. So when does the ball reach 5.5 feet? So that's the 5.5 feet for the height. We're going to put that in there. We're going to solve this using the quadratic formula because these numbers are kind of big. They're not super nice. It's possible that it's factorable, but it's unlikely. Solving with completing the square is going to give us kind of crazy decimal numbers. So I'm going to make this equal to 0 by just subtracting 5.5 from both sides, and I'm moving it over here because that's the constant. This is just a number. It's not a t squared term or a t term. That's going to give me this, which is t squared plus 45t, and then that is going to be a minus 3. So from here, we'll use the quadratic formula. So it's going to look like this. X equals the opposite of b plus or minus the square root, and then it's going to be b squared minus 4 times a times c all over 2 times the a value. Now this looks fairly intimidating, right? Because we got a lot going on. These are big numbers. What I would recommend doing is typing this into the calculator first, just the discriminant, to get that down to something a little bit more manageable to type in one fell swoop. So we'll do 45 squared minus 4 times a negative 16 times a negative 3, and that's going to give us this number, 1,833, which is big, but it's going to be faster to type in. Plus or minus the square root of, what did we say it was? 1,833. And I might as well just multiply this out. It's going to be minus 32. All right, now this is easier to type in just to the calculator. I want to get my answers. Negative 45 plus the square root of 1833 And really, I should have this whole thing in parentheses. So I'm going to go back and I'm just going to insert a set of parentheses. So my whole numerator is in parentheses. Then I can divide that by negative 32. And that's going to give me about 0.07. I'm going to round that to about 0.7. So x is about 0.07. And then I'll do the same thing in the calculator, but I'm just going to change that plus to a minus. You can only do one answer at a time. And this is about 2.74. All right, so these are our answers. So let's just talk briefly about what they mean. These answers are the time it is going to take for that football to reach 5.5 feet. 0.07 seconds and 2.74 seconds. And this should make sense if we think about the context. I'll try to draw like a little picture here of what's going on, right? We're on the ground. Got a kicker here. He kicks the ball 2.5 feet off the ground, right? So the ball here, it goes over here and it lands. Doesn't go underground. Well, this starts at 2.5 feet. We want to know when it gets to 5.5 feet. Well, it's going to get to 5.5 feet pretty quick, right? He's just kicking it directly up. So it makes sense that there we have 0.07. So probably right around here is when we have 0.07 seconds. And then it's going to come back down, and before it hits the ground, it's going to hit 5.5 feet again, and that's going to take about 2.74 seconds for that to happen. So hopefully it does make sense as to why we have two answers and why one answer is a very small decimal, right? After it kicks, it probably gets to 5.5 feet quickly, and then it takes a few more seconds to get all the way back down. Hope that's helpful. Message me anytime with questions.